Alright, before we can go any farther, I have to tell you about cell notation. It's a really simple way to express cells in shorthand. So we've discussed the copper zinc cell, you saw the cell. This is a way of writing it really quickly. So you have solid copper in contact with copper 2 ions, which are separated by a boundary. In our example, it was a U-tube with zinc ions that's in contact with zinc. So just to be clear here, a single line indicates a phase boundary. So it's the difference between solid and liquid. All right. The double line is the physical boundary that separates the two half cells. So copper with copper ions, that's a copper half cell. Zinc with zinc ions is a zinc half cell. All right. Now I want to show you what kind of question I can ask you. I can ask you to determine the anode, cathode, and net cell reaction for a cell, and then I show it to you in shorthand. So this is a lead cadmium cell. Okay? We need to find the SOA and the SRA, and we're all getting really good at it. Let me get my data table. I spilled stuff on it. Doesn't look so good anymore. All right? I'm looking for lead and I'm looking for cadmium. Let's start at the top and work our way down. Here's lead. Lead 2 ions, solid lead. Hey, that's what we got. Okay? So I think that the lead 2 ions are going to be our SOA. Okay. Now let's find cadmium. I'll start at the bottom and work my way up. Here it is. Okay, oxidizing the cadmium 2. That's good news. All right. The net cell reaction is just going to be when you combine these two half reactions. That'll be real simple. Now we just have to identify the anode and the cathode. Well, I hope you remember my story of going to the farm and seeing the red cat and an ox. The SOA, that gets reduced, gaining electrons, that's reduction. So that occurs at the cathode. The cathode is the solid, so lead is the cathode. Okay. The SRA gets oxidized. The cadmium is being oxidized. It's the anode. Looks good.